I've got my little CoreXY machine here running really well using a Duet 2 Wi-Fi control board, a BLTouch bed leveling sensor, and a Mosquito hot end. I can control it from any web browser, from a phone, a computer, or a tablet, which gives me the ability to track print progress or change firmware settings right through the web interface here. It's super easy. But most importantly with this printer, something you haven't seen before, I can turn off the printer with a touch of a button. That means that I can put that little bit of G-code at the end of my sliced files and have the printer turn itself off once the print is finished. This little button at the front allows me to turn the printer on instead of having to reach around to the back, which is nice. And the high temperature thermistor from Slice Engineering that goes with their Mosquito hot end allows me to print up to, well, I think 450 degrees. So PEEK or polycarbonate are totally viable options for printing on this printer.
See, that's a polycarbonate test print peeling off the bed right there.
Finally, the magnetic bed allows me to easily pop off my surface or print surface. I can quickly and easily pop prints off with the flexible magnet there. And I can replace that print surface with some borosilicate glass, which will allow me to print with flexible materials such as TPU or TPE. And the reason you would want to do that is because PEI print surfaces tend to stick too well to flexibles, which ruins the print surface. So borosilicate glass for flexibles is the way to go. But with many other printers, you can't quickly and easily switch between the very thin, flexible print surface and the thicker borosilicate glass. But with this printer, it's as simple as running a G29 command. It's as easy as that, but there's lots of interesting details to talk about, so let's jump back in time to last week when I first started doing these modifications, and we can talk about all of the interesting tidbits. It's been 11 months since I last worked on the Two Trees Sapphire 3D printer here, and a lot of interesting things have happened related to this printer in those 11 months. So we're going to cover those interesting things here in just a second, but first, let's put this into context. The Two Trees Sapphire is a CoreXY printer, and CoreXY is the Goldilocks frame design. It really is the best combination of all the trade-offs. There's always trade-offs, right? So this happens to be the best combination of speed and part accuracy that you can get, and it's also relatively inexpensive. So what does that mean? Basically, you've got Delta printers. These are the fastest printers that you can make. They're also very cool as far as watching them move. It looks like science fiction, but part accuracy is a problem. Getting perfectly accurate dimensions on your prints is very difficult to achieve. Possible, but very difficult. Now, the Mendel style frames like this Ender 3 Pro here produce great part accuracy, but they move very slow. And the reason for that is the bed weighs a lot. And, Newton's law of inertia says that a body that's moving wants to keep moving. And so by constantly changing directions on that heavy bed, you're having to counteract that momentum. And, a 3D printer is not that strong. The motors aren't that strong, and it's not that stiff. And so you get wiggle in the frame, and that manifests on your parts as ringing or ghosting or whatever you want to put it. And if you're really trying to move it fast, the stepper motors are going to skip and you're going to get layer shifting. So that's limited in speed. So right in between those two frame designs is CoreXY, where the only movement that the bed does is in Z, so it moves very slowly. And the lighter weight components here are doing the X and Y movement. So CoreXY is definitely the frame type that we should all be using. This is superior for sure. And proof of that is the fact that in this Stratasys patent drawing, they're using a CoreXY system. So Stratasys, for those of you who don't know, is one of the companies, probably the most influential company as far as developing the technology from 20 years ago that we are all now using in the DIY maker community to make our 3D printers. So basically they hired the smartest engineers at this multi-million-dollar company to come up with the absolute best frame design that they could come up with, and they settled on CoreXY. That was their answer. So I don't think that any of us are going to be that much smarter, if at all smarter, than the engineers there at Stratasys, and we should probably follow their lead and all be switching to CoreXY. It's the way to go. Okay, so now the interesting things about this particular printer, the Sapphire. First of all, Two Trees released a new version of it called the Pro, but it's not Pro. They did not fix the #1 problem that all of the reviewers told them about, and that is this absolute crap hot end. This thing is garbage. It has massive heat creep issues. Anybody can look at this who knows anything about thermodynamics and how to move heat through parts, and they can see that those part cooling fins on one side are not going to be sufficient to accurately isolate the heat down here in the heater block. So in the last video that I made about this printer, I upgraded to a Slice Engineering Mosquito hot end, which is an awesome hot end, and I got really great results, and I've been using this printer for the last 11 months, off and on. I've got a lot of printers, but I've used this one, and I'm really happy with the results. So yeah, thing #1 that they did wrong with the Pro is they didn't upgrade the hot end. Instead, they decided to, this creates more friction. It's harder for the filament to move through this. So instead of fixing the problem, they put a Band-Aid on it by replacing this knockoff E3D Titan extruder. This isn't, strictly speaking, a knockoff. It's changed a little bit, enough to where I can say they get a pass. It's a slim pass, but they get a pass as far as this being a knockoff. However, they replaced this extruder with a knockoff Bondtech. It's a stolen product, and that's just immoral. Of course, what do we expect from China? They're going to steal all of our ideas from the West. That's what they do. So yeah, the Pro is not an upgrade, and the final reason why it's not an upgrade is because they removed these wonderful rods. You see these rods? These connect to the stepper motors down underneath the bed, which isolates them from a heated chamber. So when you want to enclose this printer, and we all want to enclose our printers, go watch my last video, you'll see the reasons for that. But you can no longer enclose this and still isolate those stepper motors. They're going to be up here in the heat. So there's nothing that's an upgrade to the Sapphire Pro, and you should all be buying the Sapphire if you can find it. There's a couple of websites that still have inventory on the regular Sapphire, so this is the one to buy, and I'm pretty happy to have it. And what I'm going to do in this video is really get it up to a fully functional level by getting rid of the crap Lurge board. Oh, another interesting thing that happened. The Lurge board used to have a website for configuring for building the configuration file to run your Lurge board for whatever printer you wanted to run it on. And that website was an absolute knockoff copycat, violating copyright of the RapRap firmware website for building firmware for your Duet control board. And so it got taken down. You can no longer find that. So score 1 for the West, from the thievery that China does. But so you can no longer build a configuration file online for your Lurge control board because China hasn't figured out how to do that for themselves. They only know how to copy off of the West's test questions. They're just cheaters. So it's been a year. You'd think they could have come up with their own online configuration website without having to copy the one from RepRap. But nope, they're not capable. They cannot do anything that doesn't copy. So anyway, we're going to install the original, the best Duet 2 Wi-Fi board onto this printer and actually be able to use that online configuration tool because these guys are the ones that wrote that website, and it's very easy to use. We're also going to install this high temperature thermistor and talk about why a thermistor might be superior to a thermocouple. And finally, we're just going to kind of massage this thing, move some of the components around that were kind of placed in the wrong place from the factory. And when I'm all said and done, I think this is going to be my Goldilocks printer. The best combination of speed and part accuracy and just beautiful prints. So let's see if I can achieve what I'm setting out to do, starting now. All right, so there's a number of things to talk about before I start, unbolting things from this printer. First of all, let's go back to this heater block. Look at how chunky those fins are. Those were made with a CNC machine most likely, where that's the width of the bit that you see there. And the fins don't even go halfway through the heater block. So that means that at best, you're stripping the heat off of just this half of the throat where the filament has to pass through it, and not the back half, So this is something that a first-year engineering student might try. This is their first iteration, and very quickly they're going to realize why this is faulty. This is not a professional product. This is something that they should be ashamed to be selling in the year 2020 from China. This is just embarrassing. So in contrast, let's look at the gold standard. There are better hot ends out there now, but this is the heatsink from an E3D V6. Look at how skinny the fins are. Those have much more surface area for stripping the heat away, and they're 360 degrees around that throat. So you are getting full cooling of the filament path. That is how it should be done. This is a joke. This is a laughing matter. Seriously, you should point at these people and laugh because they're dumb. Now, in your hot end, you've got this little hole here where the temperature reading device sits. So this is a thermistor that we're all used to seeing. Everybody has probably played with one of these on their printer at some point. And a thermistor is a resistor that varies the resistance based on how hot or how cold it is. And so that's how it works. This here is a thermocouple, and you can't see that very well because there's not like a big sensor, but right there at the tip is two dissimilar metals that are bonded together, and as they heat and cool, the dissimilar metals create a change in resistance as well. But it's a slightly different technique than a thermistor, that being a resistor. So yeah, the easy thing about a thermistor is it doesn't require a whole secondary logic board to go along with it, whereas a thermocouple does require that. So here in the Duet ecosystem, they make this thermocouple daughter board. That's not cheap. It's like 30 bucks coming from Duet. And if you have an old Ramps style, Marlin running electronics, you can get one of these for like, $3 from China or something like that. So it is very cheap, and you can easily bolt on a thermocouple. But thermocouples are not as desirable. They're not quite as accurate or something. It's just, they're not as good as thermistors as this technique. The problem is that this only gets to 265 degrees accurately, and then it stops working. So Slice Engineering, these guys, came up with this thermistor, which is sweet. It will measure much higher temperatures than this one, but it does not require the fancy, expensive electronics of the thermocouple. So we're going to be installing this and getting it to work with the Duet board in this video as well. So here's my Duet board, brand new, in the box. That'll be, the typical installation that I do for all of my printers. But the final thing to go along with the Duet board is we're going to get rid of this touch sensor. Now this is meant to sort of, sit on the bed as the, hot end comes along and touches it. It pinches between the bed and that, sensor right there. So that is a nice, inexpensive solution if you're just trying to bottom dollar your printer, but it's extremely inconvenient, and it actually takes a little bit of skill to follow along with the hot end as you're trying to measure the levelness of your bed. A much better solution here would be a BLTouch sensor, and you can see I've got one installed right there, which is awesome. And if I turn this printer on, we can see that the BLTouch went through its startup routine, but the Lurge control board here is so undeveloped and still in beta test, level of functionality that it has all the plugs, and the software is supposed to be able to integrate with BLTouch, but that functionality just doesn't work. So China strikes again. We have to install the Duet board if we want to get functionality of the BLTouch sensor. So let's start the time lapse, and I'll get this work done. And as it goes with all remodel projects, the first step is always to tear it all down and tear all the bad things out so that you can make room for the new good things to be installed. There's a few things to talk about here. First of all, I've got this, made in the USA Slice Engineering Mosquito hot end. You can follow that link right there if you want to see the video where I installed that and, made this geometry here. But I didn't get this thermistor installed until just now, and it's got a bit of slide, so it can slide in and out of the hole there. And I ordered this paste, this boron nitride paste here from Slice Engineering as well. So I pretty much need to use these like Q-tip looking things to fill that hole with boron nitride paste. And I'm also going to do the same for the hole right beneath it, which houses the the heater cartridge, which, you know, warms the hot end there. Underneath here, we can see I've removed the Lurge control board as well as the screen. So my new Duet Wi-Fi, Duet 2 Wi-Fi, is going to go right there. And so I've got, you know, some thinking to do. Do I want to use these same standoffs and 3D print some kind of geometry so that I can mount, you know, adapt these mounting points to the Duet board? Or do I want to just drill new holes through this plate here and then use these exact standoffs? I think I'm going to drill new holes. It's just the easiest thing to do. Now the Lurge board, actually I should say the the printer came with this power switch, and this power switch controls this module here, which, you know, controls whether or not the power supply is getting power or not. This was the stock connector, and I marked the wires red for 5 volts, black for ground, and the unmarked white line is the signal, which can handle either 3.5 volts or 5 volts. So the first 2 holes I drilled from the top, as you can see here, and I just lined those up with the Duet board. And the next 2 holes I drilled from the bottom, and I didn't even have to disassemble the frame in order to drill those holes. And I'm left with a beautiful mount job using the stock standoffs with the board in the stock location and only 4 unused holes drilled in the base. All right, let's talk about this wiring job. Now, in the description down below, I will link a couple of other videos where I talk more in depth about the issues with wiring a Duet board. I'm going to try to skip over it quickly here because I think most of you guys have seen this before on my channel. So there's a schematic also linked in the description down below where I show where I wired everything. But the highlights here, the things that are different, I wired the BLTouch probe here into a different pin. You can see that's going to be heater pin 4. Normally I use heater pin 3. And heater pin 4 here is being used for the on-off switch, which goes to this control board here. That is the Lurge power control board that came with the printer. You can buy these separately though. They're like $25, and they come with the button up here, you know, that controls the on, that turns it on from the front of the machine. So this pin right here is sending 3.3 volt signal. So it either turns on or it stays off. When it's off, the relay keeps the whole printer turned on, and when you send that 3.3 volts, it flips the relay and the printer turns off. These 2, you know, power and ground are just meant to feed the relay just to kind of keep it operational. But that right there, that's the signal pin, and that's the important bit that you're going to have to control in firmware. For the rest of it, it's just the standard way I do things. So it goes Z, that's your Z stepper motor down there, Y going to there, and then X going to there, and then that's your extruder stepper motor. And all I did for those plugs is the typical deal where the plug looks like this with some tangs that stick off the side, and you basically just go in there and you use your flush cutter to cut the tangs off so that it can slide into the onto the pins. Now, this will not engage with the actual clip. See, there's a plastic tang there that's meant to engage. So these are incompatible as far as the clips engaging, but the pin spacing is the same. So you're able to slide that down over there without having to switch any of these wires up. Of course, your Duet board will have come with a bunch of these little metal crimp connectors, as well as the plastic plugs that are meant to, you know, properly engage with the board. So in order to get these installed, you're going to need a special tool, and that is this one right here. You will need the ones with the EDM wire cut jaws. These are available on eBay or Amazon or AliExpress or whatever, but get the good ones, because the ones with the, you know, molded jaws just don't have the tolerances. They don't work. So you definitely need the more expensive version of this. And thanks again, Nikhil, for buying this one for me. So in order to do this, you basically just strip your wire. Then I sort of pre-crimp it with some long needle nose just to kind of hold it in place. And you can see my wire is extending into these 2 flaps, whereas the insulation is just being held by the back flaps. Now I carefully line it up. You see in the jaws there's the sort of like halfway seam looking thing. So you line up that line with the insulation, and then you just crimp it on down. And that's a nice crimp job. You can see just how nicely it bites into the insulation. And after you've done that, you can just slide it into the plug. So that's the difficult way, but the proper way to set up the wiring for your Duet board. But I kind of prefer the hack job. It's just easier. Now you can see I've got the wiring that comes through from underneath through this hole back here, and it's being routed through this conduit piping. I don't know the technical name for this plastic hose. But getting your bundle of wires inside of this hose can be very time-consuming and difficult. You got to kind of spread that apart like so and try to shove it in there. It's not easy. So I came up with this special tool, and I will throw this tool up on Thingiverse. So the way this works is you basically just hold the end there, you stick it into your pipe, and then you sort of slide it in. And it allows you to just sort of zipper the wiring into the hose. Pretty cool, huh? So yeah, I think this is, I went looking for other solutions that other people had come up with, and I couldn't find anything that works. Getting your Duet board running with its firmware and also connected to your Wi-Fi router is super easy. Basically, it's a two-step process. Step one is connect to your Duet board through a terminal program. I'm using YAT here. And once you're connected, you can just type in the command M115 to make sure you're connected, and we can see that I'm running version 2.05.1 of the firmware. Now, as I record this, 3.0, actually I think 3.01, is available for download. But version 3 of RepRap firmware is sort of a unified thing where it's meant to work on Duet 3 as well as Duet 2 boards. And it's because it's trying to, serve all those needs, things have been changed around quite a bit, so it's a bit different, and there's a learning curve there, so I prefer 2.0 as far as that goes. And also, firmware version to go with version 2 of the control boards seems to make sense to me. The version 3, it's technically out of beta testing, but it's still problematic for me. So I still prefer, as far as usability goes, I still prefer the 2s. That might change here in the near future, but yeah, check back, I guess. Watch more videos of mine and look for those updates. But for now, it's version 2.05.1 for me, and I'm already connected with this board. And I'm not going to go through the steps, but basically you just have to teach it your Wi-Fi credentials, the actual name of your network, as well as the password. Link in the description to a video where I go into the nitty-gritty details about this process. Anyway, once you've taught the Duet board about the Wi-Fi credentials, you can just log into the Duet board through any web browser. And we can see, I'm looking at it here on my computer, and I can do things like home all, or if there's a job running, well, there's a list of the jobs that I can send. If there's a job running, that's the status. It'll give me, a timeline, how much each layer is taking to print, and all that kind of stuff. Everything you need to know. But the most fantastic thing about Duet boards, which you cannot find on any other operating system, firmware, or control board, is the ability to go in here and to manipulate the firmware configuration. Now you don't get into the back end on the firmware. You still need to, program that and compile it and then upload it if you really want to, it's open source. You can do it. You can go get into the back end if you really want to. But even for the configuration, it's just right there. It's fantastic. That, as a normal user, gives you all the control that you could possibly want from your printer. And if you don't want to do it here in this text editor, and this is just G codes. All these are just G codes. M569, that's a G code. You can look that up on the Duet G code reference sheet. But if you don't want to get into the text editing, you can click on this little button right here, Edit via Config tool, and it will open up the online configuration assistant, where you basically just got little fields and little buttons to click for all the settings that you would want to change. When you get to the Finish tab, you can add some custom bits of code or G code in there. And I've added everything you can see there that we'll need to get this particular machine running. And then you just click on the Finish button. Download configuration bundle there, that's your firmware settings. And then if you want to update the actual firmware itself, you download that link right there. And if you want to update the actual website for getting into your printer, that's this interface. You click on the Duet web control. So super duper easy. It's getting better and better as time goes on. There was a time, for instance, in order to get BLTouch functionality to work, you needed to type in I1 to invert the BLTouch signal. You needed to do that by hand here in config.g. But now, as you can see, the way that it builds your, let's see, deploy probe, see, it's already built in there, I1. So you don't need to do any text editing if that's not your bag. But if you do want to get into it and be a power user, it's all there at your fingertips, at your disposal to tweak your machine to your heart's content. You have the power. All right, let's talk about test prints. Here on the left, we see the yellow one. That is the very first print that I ever made on this machine, and it is darn good, you guys, like really good. Even with that horrible stock hot end cooling fin, heat sink design. As long as you can get the filament to feed through that terrible heat sink, you can get tremendous print quality from this machine in its stock form. The green one here is with the stock electronics, but with the, the Mosquito from Slice Engineering, the Mosquito hot end. And there's almost no difference in quality. In fact, I can't tell a difference between these two. They're just as good as anything I've ever made. So, yeah. The blue ones here were all done with the latest setup. That would be the Mosquito hot end and the Duet control board. And these are as good as the other two, so we're not losing anything in quality, at least not with this slow speed. Now this one was printed for 29 minutes and 38 seconds. And you can see there is zero ghosting, like not even the hint of ghosting, especially in the X direction, but the Y direction here, that would be printed in that orientation, just like that. So the Y orientation has the hot end along with the crossbar, all of that weight moving back and forth up and down the bed, and that's what causes the rippling. Because trying to stop and start weight, the heavier the heavier the mass that you're trying to move, the harder it is to stop it and get it to move the opposite direction. So, yeah, at this slow speed, print quality is just as good as anything. I'll pit that print quality against the Prusa any day of the week. I know that there's not a printer on the market. There's like an upper limit to how good you can print, how good of a print you can achieve with any of these FDM 3D printers. So this print definitely, crosses that bar. Look, I just broke the tip off it dropping it. Anyway, these two prints here, I just wanted to see how much quicker I could print. So this one here was a 14-minute print, exactly 14 minutes. By circumstance. And we can see up here near the top, it starts to get kind of ugly in the spire, and that's a failure of part cooling. So it's moving too quick for this little part cooling fan to keep up with it. You see that same sort of a thing happening with the bridging, the ceiling there. Look at how much, of a quality decrease there is between the bridging on this part. And yeah, that's all 100% part cooling. But there's a problem here that's not part cooling, and that is this little lip. So here, let me use this spire to point at it. See that little sort of changes in, it's sort of like bulged out there along that edge? That is an artifact that comes from the long Bowden tube on this printer. So I need to shorten that Bowden tube in order to alleviate that problem with the hardware, but there's a software fix potentially, and that is called Linear Advance. Well, it's called Linear Advance in Marlin, which is what everybody's familiar with, but it's called Pressure Advance in Duet. And I kind of think that by the naming, the nomenclature there, maybe Duet thought of this technique first. But anyway, that's all open source, so they, all the firmwares copy, features from each other. So yeah. So anyway, Pressure Advance will allow me to potentially tune that out of the machine, and also potentially I could tune out any rippling or ghosting, if there was any, using dynamic acceleration adjustment. And so here on the print that only took 11 minutes and 36 seconds to print, we can start to see some small rippling artifacts. They're really pretty faint, but they're there. And I had the acceleration and the jerk settings turned way up, 50% higher than I did on these two. So that's why we start to see the rippling on this 11-minute print. So yeah, basically with a shorter Bowden tube, better part cooling, and those other two bits of fanciness tuned in the firmware, I think that I could get an 11-minute print that looks every bit as good as these other ones here. And let's talk for just a second about this polycarbonate print. I did not finish printing this Getting this printer tuned and dialed in with polycarbonate is going to be a subject of a later video. But yeah, I was super impressed with the Mosquito's hot end, the ability of that hot end to print the highest temperature plastic that I have, 330 degrees, printing this polycarbonate print. And then I instantly dropped the temperature down, for PLA, and I was able to flush all of the polycarbonate using the PLA at 265 degrees. So I basically dropped the temperature to 265 degrees, then dropped the temperature to 200 degrees, and as the temperature was falling, I was feeding PLA through it, and it flushed out the polycarbonate without an issue. That is super impressive, you guys. I've never been able to go from such a high temperature plastic to a low temperature plastic without feeling, because I'm doing this by hand, and I would always feel the resistance from the hot end, and I could not feel any of the resistance here. Now, the question is, should you buy this printer and put all of the upgrades on it yourself? First of all, the non-pro version of this, the Sapphire normal, is still for sale, yes. But when I reviewed this printer last year, it was only $350. Some people, like GearBest, still have inventory on the regular version of this, but it costs $469. So more than $100 price increase. And by the time you add in the Slice engineering components, I paid $250 for all of those components. And the Duet control board, that's $175. And then you've got this detachable, flexible, printing surface. That's going to be another $40. So you're above $900 now for this printer. Darn near $1,000 to get the same functionality that you're going to get out of my Ender 3 Evolution project here. Now, if you haven't seen this video, seriously, go watch it. It's amazing. That I was able to get this level of performance and all of these features packed into this printer for, I think this one was $490, just under $500, but you could probably make this build happen for $400. So pretty darn cheap for filament runout, direct drive, which means that all those issues I was getting because of the Bowden tube, you're not going to have those issues with the direct drive, but because of the inertial mass on the bed, as well as the inertial mass of the direct drive, you're going to print more slowly. So if you want a printer that prints very fast, also very accurately, and you can put it in an enclosure for printing with with polycarbonate or PEEK, yeah, that's your printer. This is the total winner for that. And I'm definitely going to enclose it with a much better technique than the last video about the enclosure that I made. That's the plan for me. And there's no other way to achieve that goal. There's no printer that's better than this one, because all of the electronics, the stepper motors, the control board, the switch, everything is contained beneath the floor. It's very clever engineering there. And all of the guide rails and really everything up here that matters, except for the belts, which are, a rubber with some sort of a filament stranded inside the rubber. But everything else is metal, so it won't be, it'll expand in the heat, sure, but for the rest of it, it'll function just fine in that extremely hot environment of a heated chamber. Now, the CoreXY printer, which I love, is of marginal utility when you're talking about a printer of this size or this size. These are the same size bed. In fact, this one is a little bit larger, 235, and that's 220, squared for the bed dimension. So the weight of this crossbar combined with the weight of the X carriage that has to move up and down in the Y-axis, I think that's going to be about equivalent to the weight of this bed here on the Ender 3. And look at like a Prusa, for instance. I think that the weight of the Prusa bed that's moving, it's still quite heavy, but I think it's going to weigh less than this. So as far as the inertial mass argument goes, for small form factor printers, CoreXY does not make sense for inertial mass. This particular CoreXY design makes a lot of sense for this printer because it moves all of the components beneath the floor for high temperature printing. But as far as inertial mass, it doesn't make a difference. It might as well be that printer. In fact, it's the same. So no sense in spending the extra money for CoreXY for small form factor. CoreXY is brilliant, and I absolutely want to see more and more CoreXY printers on the market. Please Manufacturers, please, people, start buying these so that the manufacturers will start making them for us, because we need large format CoreXY printers. As you get larger, the surface area, in other words, the size of the bed, the amount of mass that you're moving is like exponentially increasing. But that's not true for a single bar across the top. That mass does not increase exponentially with a bed increase. So this is the way to build a printer for large format. You should not have large format printers with a bed that moves in the y-axis. That's just stupid. Stop buying those printers. They're a waste of your money. Okay, CoreXY, large format. Mendel, this size. While I'm being all forceful with my words and verging on a rant, let me talk about the Ender 5. So the Ender 5, you can see it in the background here. It's not an CoreXY design. It's not CoreXY. If you look close, you can see that stepper motor there attached to the gantry. So you got the gantry, you got the hot end weight, and you have that stepper motor weight now. All those things combined mean that the y-axis, the amount of weight, the inertial mass in the y-axis is the same, or maybe even increased compared to the Ender 3. So there's absolutely no benefit to this frame here over the Ender 3. You'd be better served to save hundreds of dollars by buying an Ender 3. So there are other frame designs which can rival CoreXY as far as the inertial mass reduction goes, but this is not one of them. All right, well, I can't think of anything else to say, so here is a link to a video that YouTube thinks you want to watch, and there is a link to my Patreon page if you want access to any of the digital files I've made for this printer, the firmware files, the printable files for holding your hot end and the cooling, all that. For this printer, or for this one, or for any of the other printers that I've made, that's how you get those over there on Patreon. Thanks for watching. See you next time.